Alright, so in the last video we left off looking at the loop method, which takes a block, and what will happen is that the loop method will continue to call that block of code over and over and over again. In fact, it's a good way to get into what's known as an infinite loop. For example, let's in IRB here, let's say loop do, and then we'll just tell it to puts I'm looping, just like this, and we'll end that off. Now when we execute this code here, we'll see a lot of output go by here. So we see that our screen filled up here. It doesn't look like it's moving, but in fact, if I start scrolling up here and you see the size of the little scroll slider right here, it goes quite a long ways, and we are now stuck in what is known as an infinite loop. And you can see the slider moving because it's still going and going and going. So what we've done here is we are continuously calling that block of code, and it's just going to go on for eternity here if we let it. So if you ever find yourself stuck in a situation like this in an infinite loop, what you can do is hit Control-C, and it will go ahead and terminate that and get you out of that loop. And again, so we can see here we outputted that quite a lot of times here. So infinite loops are something that you want to be mindful of. You don't want to get stuck with them, but if you find yourself in one, remember Control-C to get out of it. One of the other things we looked at in a previous video was the times method. We looked at it very briefly, so let's do the same thing, but times is a good way to do a similar thing as to what we just did, but not end up in an infinite loop. So let's just say 20.times do. We're not going to use the block argument here. The times method will yield, if you remember from the previous video, if you want, you can accept an argument into the block to be used in the block of code, and it will be the each iteration's number variable that it's on. And remember, that starts at 0, so be mindful of that. But each time it calls the block of code, that number will increase by 1 until we get until it executes the block code 20 times. We're not going to do that here. Let's just print out the same message and say I'm looping, just like that. Or let's actually put the little ellipsis dots at the end here, and then we'll say end. Now if we run this code, we see that it only executed 20 times, and then times method doesn't call the block of code any longer, and it returns back to us the number 20, which is the object that we called the times method on. Let's look at another method that can take a block. So something that's somewhat similar to the times method here is the up to method. Now we can say 1.upto, and then the up to method takes an argument, let's say 10 here. Okay, 1.upto 10, and then this takes a block as well. So we'll say do in this case, and then let's just print out our message here. We can take the number again as a block argument, much like we could do if we wanted to up here with the times method. We're not going to do that in this case. Let's just say puts going up, just like that, and we'll end our block. Okay, and then we see that it prints that out 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Let's actually look at what happens if we pull the block argument, in this case with the up to method. And let's look at an alternative syntax for writing blocks too. If you remember from yet another previous video, I mentioned that there's 2 different ways to write them. The first was the kind we've been seeing the most here, the do end syntax. Really good if you have multi-line code blocks that you want to pass into a method. The alternative syntax, if your code is short enough to fit on one line, is to use the curly brace syntax. So let's look at that now with the same example as before. So say 1.upto 10, okay? And then after this, we will declare our curly brace block with an opening curly brace. And let's go ahead and take the block argument this time, and just so we can see what the number is, what the starting point is. Is it the same as with the times method where it starts at 0, or does it start at 1? Let's find out. So we'll take the block argument there, and let's just print that out actually, or let's puts it out. So we'll just say puts in, and then we'll end our block with a closing curly brace. Now if we hit enter on this, we will see that it starts at 1 and goes up to 10. Now, it doesn't have to start at 1. We could alternatively say, let's start at 5 here and go up to 100, for example. So if we do that, let's run this code and see what happens. So we see we went up to 100, but we started at 5 in this case. So this is a handy little feature to know of the up to method. There's also a down to method as well. So we could say, let's flip this. Let's go back to 10. Actually, let's change this to 5. I'm sorry, because we're going down to. Let's go down to 2, and we'll say 10 dot down to 2, and we'll puts out the number, the block argument here, and we see we start at 10 and we go down to 2. So let's look at a couple other options we have for looping. We have while loops, and also we have until loops. And basically those will loop until a certain condition becomes either true or false. So let's look at the while loop first here. The way we set up our while loop is by using the while keyword, just like this, while. And then while takes a condition, and it will take that condition and evaluate it and use that result to decide whether or not to run the code within the body of our while loop here. So let's say, for example, let's just say while num is less than or equal to 50, we'll just say puts not greater than or equal to 50 yet. Okay, just like that. And then let's see what happens. As we saw previously, a good way to get yourself into an infinite loop is to forget right here to increment the variable num before the loop restarts. So let's look at that right now. If we just hit in, or if we just write our in keyword right here and hit enter, we're going to see that we are going to end up in yet again another infinite loop. You can see over here the scroll little slider over here is just going up and up and up. We are stuck in an infinite loop. So remember, we'll get out of that with Control C. All right, so I'm going to clear my terminal here, and let's rewrite that. Let's say while num is less than or equal to 50, we want to put not greater than or equal to 50 yet, just like that. Now what we want to make sure to do inside of here is to increment the value that the num local variable is pointing to. So what we can do here is we can say num, we can say plus equals num plus 1. We can do it that way. Oops, sorry, let me get my space in there. We can do it that way, or we can use the shorthand operators that we saw way in the beginning of the section here. And we can just say num plus equals 1, and then we'll hit end. And now if we hit enter on this, we will see that our code correctly loops over the given the value or the result of this condition here, right? So first time through, num is 5. Num is less than 50 in that case, so that returns true. So while true, right, let's go ahead and print this out. And before we loop back, though, we want to make sure to increment that number so that we get closer to 50, right, each time. So we can see here that we executed that body of the loop here a bunch of times, and then it just simply exits. I'm going to go ahead and clear out my terminal, and we'll look at the until loop next. So we still have our num local variable here. It's set to 51 though, so because we incremented it all through our last bit of our while loop. So let's go ahead and reset it to 5 again and start over. Okay, so num is now 5, right? Now the until loop uses the until keyword. So we would just say until, and then that also takes a condition. Now this time we want to say until num is greater than 50, execute the code that we're going to put inside the body of this loop here. So we'll say until num is greater than 50, puts not, let's just say not there yet. Okay, we'll end off our string here. And then we want to also, again, make sure to increment that local variable at the end of the loop here before it starts back over. Otherwise, we're going to end up in an infinite loop. So we'll say num, we'll do the shorthand again, plus equals 1, and then we'll hit end, and then we'll enter that code. and we see, just like with the while loop, it looped until the condition was true. All right, so now let's talk a little bit more about blocks. So I'm going to clear out my terminal here so we can get a nice blank slate to start with. Let's define a local variable called nums in this case, and that's going to point to an array of integers. Let's just say 1 through 5 here in this case, okay? So that we have our array here, and let's say we wanted to go through this entire array and print out the value of each element, or print out each element, right? So one way we could do that is by using the each method. So what we would do is we could say nums.each. Now each takes a block. Now we've seen previously that blocks can be written in 2 different syntaxes. Let's quickly review those again. So we can use the curly braces, and then it can take each can pass off a block parameter here. So we can say, let's just say num in this case, okay? And then let's just put num, and we'll end our block with a closing curly brace. Hit enter on this, and we see that we go through each element in the array, and we print out that element to our terminal here. Alternatively, we could do the do end syntax. We could say nums.each, do, take our block argument again of num off, and puts num. And then we'll do make sure to add the end keyword right here. And if we hit enter on this, we get the same thing as a result here. Again, use case wise, if your code is short enough to fit on one line, most folks tend to reach for the curly brace syntax. If you're going to do a lot of things inside your code block, people tend to do the do end syntax so that they can put kind of each step on its own line essentially. Now, let's talk about what code blocks are. Code blocks are essentially methods, but they don't have any names associated with them. That they're nameless methods or nameless functions, right? And some of the nifty things about them is that they can be passed to other methods, or they can be stored for later use. So let's say now we have an array called negative nums, okay? So we'll have a local variable, negative nums, that points to an array of -1, -2, -3, -4, -5, all right? So what if we wanted to return an array of all of the positive associated integers here, right? So one thing we could do is use another method similar to each. Now these are called iterator methods. They sequentially go through a collection and go one element or key value pair at a time, and do something with each element when past a code block. All right, so negative nums array. Let's say we wanted to get all of the absolute values for each of these numbers, so all the positive versions, right? So one thing we could do here is we could iterate over each element of this array and call the ABS method on it. Now, let's say we don't just want to print them out though. Let's say we want to have a new array returned to us of all the positive value versions of the numbers in this current array here, right? So what we can do is there's a method that we can use that the array class responds to called map. And it's similar to each, and they're both iterator methods, right? So whatever collection objects that these methods are called on, it will iterate through or sequentially go through each element in the collection one at a time. And now one of the nice things is that we've seen here, each element, when you pass those iterator methods a block, each element gets yielded to, and we'll talk more about the yield keyword in a bit here, but it gets yielded to the code block so that the block of code can run the code in the block against each element in the collection. So let's do what we were talking about a moment ago here. Let's just say positive nums is going to be, that's a local variable, we'll set equal to the result of doing what I said a moment ago, of mapping over the negative numbers array, our negative nums array, and calling ABS on each element. So we can say negative nums dot map, and now map takes a block. Let's do the do in syntax this time, or no, let's do the curly braces. We haven't been doing curly braces much. So we'll do an open curly brace. We want to take the block argument here. That will be the current number that we're on in the iteration process. So num, we just want to say num.abs, and then we want to end our code block with a closing curly brace, right? So if we hit enter on this, we see that the return value is an array of all of the absolute value or positive versions of the numbers that were in this array here. And just to be sure, let's look at, let's call positive nums. Sure enough, we get back that array. And let's look at negative nums. And we see that that contains the negative versions of all the numbers. We did not change or mutate the negative nums array. We returned a new array with the result of executing this code block here for each element. Now, one thing that's cool is that we can define our own methods that take code blocks as arguments, or that can take code blocks and use those code blocks within our methods. So let's look at an example of that now. Let's say we have a method called sum numbers. Okay, so we'll just say def sum numbers. Okay, and then the arguments that we want this method to take, let's see, we want an array. We'll just say ARR of nums to indicate that we want an array of numbers passed in here. And then in order to set up our method here so that I can take a block, what we do is we give it a parameter name or an argument name, right? So we could say code block, just like this. But what we need to do in order to indicate that this argument is a block here is we need to prefix this with an ampersand, just like this. And then let's go ahead and end our method off with the closing parenthesis. And now we're inside the body of the method. So now what we can do is we can say ARR of nums, dot each, okay, just like this. And then let's use our curly brace syntax here. So we'll open up a curly brace here. We want to take the block parameter, which will be the number of the that we're currently on in the iteration process from the each method. So we'll say num, and then what we want to do here is we want to now pass this number to the block, the code block that we're going to pass to the sum numbers method. So the way we do that is we say code block, which is referencing the argument name that we provided here. We don't use the prefix in this case inside the body here. What we do instead is we use the call method, and then we can pass the call method an argument. And in this case, we can use num, which is the block parameter here that is being passed in. And then we want to end off this code block for the each method here. So, and then let's go ahead and end our method here before we forget. Okay, we now have that sum numbers method defined. Now let's see how to use our sum numbers method here. So we would say sum numbers, just like we've seen before. Now the first argument to this needs to be an array of numbers. Let's go ahead and use our negative numbers array here. So we'll say negative numbers, okay? Now you may think that you would do something like add a comma and then maybe put a block of code in right here and say num and then puts num, something like this, and then end off the argument list. But you can see already that the syntax highlighting has kicked in, and Ruby is not happy with us for doing things this way. What you actually do is just like we saw here with the map method, we actually just have the map method and then we pass the block after it. So the way we write this right here is we would do end our argument list off with this closing parenthesis and then pass the block after that right here. So let's just say do, and then we want to make sure that we have access to the number that is going to be yielded to our block or given to our block or passed to our block. So we'll say num in this case here. Okay, so we want to for every number that we get, let's just say we want to print out the absolute value of that number. So we'll say puts num.abs, and we'll end off that block and hit enter, and we see that we get the positive or the absolute values of all of the integers that were in this array. They were all negative, so we get all the positive values out of it. So just to recap that real quick, when we go to use our method, are any arguments that are not prefixed with the block here, okay? And you can only have one of these prefixed with the block. It's not going to. You can't have a method that takes multiple blocks at one call or during one call. Only the arguments that are not prefixed with the ampersand here go inside your opening and closing parentheses after you call your method. The block gets written after or outside that closing parenthesis. In this case, we did the do-in syntax. If we recall this, we can put this all in one line here. Let's do curly brace num. We'll end off our block argument there with the other vertical pipe. And we can say puts num.abs, closing curly brace, and we see that we get the exact same result. It just went ahead and called the abs method on each num variable that was passed to this block that we passed to our sum numbers method. Now, an alternative way to do this is we don't have to do this ampersand code block right here and then do code block.call and pass call an argument. Another way we can do this is by using the yield keyword inside of our method. So let's look at that now. So we'll use the same method as before. We'll use the same numbers method. So we'll redefine its def same numbers, okay? And we would still want that to take in an array of nums, okay? But that's all we're going to do here in this case. And then we'll hit enter. We'll get inside the method body here. And then we want to say array of nums, okay, dot each. And then each is a method of its own that takes a block. So we need to give it a block. Let's open up one with some curly braces here. So each, we're going to do opening curly brace to start our block here. We want to define a block parameter here. So we'll do a vertical pipe, and then we'll name it num, which will again represent each element during the iteration process as we loop over these things here in the collection of the array of numbers. So now what we can do is, instead of, like I said a moment ago up here, where we did the code, we defined the code block like this, and then we called it inside the method body, and then we called the call method on it, passed the num to it. What we can do instead is we can just say yield num, and we'll end off our block with a closing curly brace here. We'll hit enter. Oh, I mistyped yield. Yield num, end off our block, and then we'll end off our sum numbers method just like this. Okay, now we have it, and if we recall the code before, we see that we will get the same exact result to us. So it's two different styles of writing them. The yield keyword works just the same as if you have a code block being passed into it right here, and you call the call method on that block, and then you just have to remember to pass the argument that you need or that you want access to inside this block to the call method. Okay, now I mentioned earlier, I believe, that we can also store code blocks for later use. So we're going to look at that now. Let's say we have a local variable called print capitalized name, okay? And then, so that's a local variable, and we'll set that equal to a new proc object. So we'll say proc capital P, that is a built-in Ruby class here. So we'll say proc.new, and then we will pass a block to this. So let's just say open curly brace, the block argument here will be, let's just call it name, and what we want to do is puts name dot capitalize, okay, with a capitalize method here, okay? So if we hit enter on this, we see that what we get returned to us is this proc object here, okay? Now if we just simply call print capitalize name, we can still see that it just points to our proc object. We can't, it's not executing the code block that we set up here, because we're not, as we saw in our first edition of our first version of the sum numbers method, where we called the call method on a code block. We need to do that here as well in order for this to work. So what we can do is say print capitalize name dot call, and then call an argument. What do we want to capitalize? I'll just pass it my name for now, Colin, as a string. and then we see if we run this code that it will go ahead and the argument that we pass to call will get sent down to our proc object. So it comes down here, right in here inside this code block. It's held or referenced by this variable name here, this block argument. And then what we do is we just simply print out the result of calling name.capitalize. And that's what we get right here in this result. Now, one interesting thing that we can do is we can actually use this local variable and pass it to iterator methods like each and map and so forth, and get it to appear to those methods as a block. So what we can do, let's say we have an array of some names right here. Let's just say Colin and my good buddy Bob, who I just made up. I do have a friend named Bob, but this is not him. This is just a Bob. So what we could do is we can just say this array, and we can call the each method on it, and then we can actually pass this local variable to the each method and make it seem like we're passing an actual block to each, because really we will be. And now we can actually use this local variable and get it to come in as a block to the each method here. Now, the way we do that is similar to the first version of the sum numbers method, where we defined that code block argument prefixed with the ampersand symbol. We will do the same thing here. So what we can do is we can say ampersand and then print capitalized name, just like this. Now if we hit enter on this, we see that we get the result that we expected. It looped over this 2-element array of strings. Each one gets sent to the block that we passed to each as this argument right here, right? This block argument. And then it simply just calls capitalize on it, and it prints out that result. And that's what we see right here, Colin and Bob. And now similarly, we can use built-in methods in a similar way as this right here. So let's use that same array here. I'll say Colin and Bob. Okay, this is our array. And let's say in this case, let's say we want to return a new array of these elements capitalized. Okay, so we'll use map for that, since map will return to us a new array. We will say, so that Colin Bob array dot map, right? And now what we would normally just do is on a line right here, we'll just open up a curly brace. We'll say this is a name, right? And then we want to just say name dot capitalize, capitalize, just like this, right? And I'll run this. We'll see that it works. We get back that array, 2-element array, and both names are capitalized. I'm going to recall that line, and I'll show you a different way that we can use the built-in methods to shorten this up right here. So we're going to use something called the symbol to proc syntax. So what that's going to look like is we'll get rid of this block here, and actually to map, I'm going to open up a parenthesis, and I will do ampersand, colon, capitalize. There we go. And I'll end off that argument list just like that. And if I hit enter on that, you see that we get the exact same result as we did on the line before. So what it's doing here is that it is going to take this capitalize method, and for every element that map, as we iterate through this array here with map, every element is going to come into a block and have the capitalize method called on it. And then the result of that is what gets returned to us in our new array here. Let's go back and look at our sum numbers method again here, and look at something you can run into when using or when defining methods that take blocks, or using methods that take blocks and not passing them blocks. Let's look at that. So let's first do our sum numbers method, and then let's say that once takes an array of nums. And then let's use the ampersand here, and we'll just say code block, just like this, right? And then we want to say array of nums dot each do will yield, or the each method will yield to its block a number, and then we want to say code block dot call, and then pass in that num to it. Okay, and then let's end off our method here. Now let's redefine our array here. Let's just say negative nums again, is equal to an array of -1, -2. Let's just do -3 numbers this time. Okay, we'll do that. And now let's go ahead and call some numbers. Okay, some numbers. And let's just pass in the negative nums array and no block. And let's see what happens if we hit enter on this. So if we hit enter on this, we see that in this case, we get a no method error. So undefined method call for nil class, no method error is the actual name of the error that was raised here. The reason that this happens is because when we went to go call our sum numbers method and we passed in negative numbers, we did not also pass a code block to our sum numbers method. So when this method was being executed, this variable right here, or the block, was not existent. It was nil. There was no code block passed. So then we tried to call .call on nil, on the nil object, and nil does not respond to call. So that's why we get this error. Let's look at what happens when we do this using the yield method next. So let's redefine our sum numbers method here. We'll say sum numbers also takes in an array of nums. And then, in this case, we don't want to do the explicit block in our argument list here. Instead, we would just say ARR of nums dot each do num yield num, and end off the block for each and end off this method. Okay, now let's try and call some nums this way, and let's see what we get. Okay, so this time we get a different error raised. So we get a local jump error, and it says no block was given for the yield. So we tried to yield to a block here, but there was no block given, so the code had nowhere to go. We had nowhere to send this num variable to, right? So how do we get around these two things? Well, let's look at that next. So we can get around both of these errors in both cases by using a conditional check there and using a built-in method that Ruby provides called block given ? It's a predicate method here. So let's look at how we can use this in both cases here. So let's first go back to our original one, def sum numbers, where we defined array of nums, and then we did the explicit argument here for a code block. Okay, and then we'll say ARR of nums dot each, and then we'll open up our block that is passed to each. That will take the block argument of each number, and then we could say code block dot call, just like we did previously, pass in that number to call, and then at the end here we can use the modifier form of a conditional statement, of a conditional if statement, to check if a block was given. So we can say if block given, just like you see right here, and then we can end off our block, and then we'll end off our message here. So again, do this code if a block was given is what this is saying right here. So now if we try to call some nums and pass in that negative nums array and don't pass it a block, we just get back the array that was passed to the sum nums method. It doesn't. We don't get the errors because of the conditional check that we've added of checking to see if a block was passed to the method. We can do the same thing for the previous one where we did not have the explicit block argument being passed into our argument list here. So here we would do the same things. So after yield num, we could say if block given, just like that. Okay, so now we can say some numbers. Actually, let's just recall right here, and we see the same behavior happens. And also, just I think I've mentioned this offhand a little bit, but we've defined a method right here, right, and then we've redefined that method here. So when you do things like this, wherever the method is defined later, whether it be in a program file or an IRB right here, wherever that method is defined later is going to overwrite the one previously defined. So, and we'll see other cases of where we can overwrite methods from other places, like other files completely, when we start talking about inheritance and like modules and classes and stuff. But we'll cover that in a future lesson. But I just wanted to point that out, if I haven't already, that when you redefine a method later in the program, it overwrites the one before it, the definition before it. So to end out this video, let's look at one more way to create blocks here. So what we're going to look at now is something called a lambda. Now it's similar to a proc object. They're both callable objects essentially. They're both code blocks. But we'll see. Take a look in a moment about some differences between them. But let's look at first a couple ways of how we can define lambdas. So we can use lambda like this. Oh boy, if I can type lambda method here, and that takes a block. So we can say do, or we can do the curly brace syntax. Let's just do curly brace right here, and we'll just say puts hello. Okay, and we'll end off the block for the lambda method takes. And actually, let's save this off to a variable. Let's just call it, I don't know, I'll just call it L for now. So L equals lambda do puts hello end. Okay, so if we hit return on that, we see that what we get back is a proc object, and we see that it says lambda over here in parentheses. So this is one way to distinguish, like, if it's a proc or a lambda. In this case, this one is a lambda object. If we do proc.new and then block and then puts hey, right, just like this, we don't see that additional note that is a lambda down here, right? So that's, a way that Ruby keeps track of what is what here, basically, right? So now, just like if we were to save that proc object, and remember, I think I showed you this way earlier on. If you want to save the last evaluation or the last expression evaluated, if you want to save that result to a variable after you've run it, like we've done in this case, I'd like to save this proc to a variable. Let's just call it p. You can do p equals underscore, and that would be the last thing that was run. So you can see that these objects are the same things here. So similar to how we called in our code up here, how we have to call codeblock.call and optionally pass in an argument, we do the same thing for calling lambdas as we do for calling these proc objects. So let's first look at the proc. We say p.call, and then it just prints out hey to the screen. Similarly, we can do l.call, and we can see that we get the hello to the screen. So that's one way to define a lambda, by using the lambda method and passing it a block here. The other way to do it is by using something called a stabby lambda. So let's look at that next. So I'm going to say, let's make a local variable here called stabby lambda. Okay, and we'll set that equals to. Now, the syntax here is going to look very different from these two ways of creating proc objects. So the way that this works is you do a dash and then a greater than sign, and then you open up curly braces. So like you do in keywords here, right? So let's just say puts stabby lambda. Okay, just like this, and then we'll end off that. Okay, if we hit enter on that, we see that we get back a lambda proc object. Now to call this, just like before, we say stabby lambda.call. Okay, and we see that we get printed out to the screen here the string that we told it to print out, stabby lambda. Now this syntax right here, you will see used very often in Rails when you're defining scopes for your model classes. So I definitely wanted to make sure to cover this syntax here. Let's also look at how we can get arguments into this syntax now. So let's make a local variable called, let's just say greet person, okay? And we'll point that to a new little stabby lambda here that we're going to make, okay? And before we look at how to take in the arguments, let's just define kind of what we want it to do, right? So we want to open up our curly brace here, and let's just say puts hello, and then what we want to do here is like interpolate the name of the person that's passed into this lambda, okay? Oops, let me end off my string here and then end off with that closing curly brace. Now, how are we going to get this name variable into this string right here? So the way that we pass an argument in to a lambda this way is back over here where we did the greater than sign, the dash and the greater than sign, the arrow. That's the that is the stabby part of the stabby lambda terminology there. So the way that we get an argument here is that we would open up a parenthesis and we just name the variable. In this case, we're calling it name. It can be anything you want to write here. You can write whatever. You just need to make sure whatever you name it here, just like before when we've used blocks in the past, that you, in order to access that variable or that argument being passed in, you reference the same thing, the same name here and here. Currently, we're not doing that, so let's go back to name. So say name and then put a closing parenthesis right there. And now if we hit enter here, we get our lambda proc object back. And now we can say greet person and then dot call, and then we can pass in a name here. So we'll say Colin in this case. And if we hit enter on that, we see that we get hello Colin, as we would expect. Now what about passing arguments to procs? Because we haven't looked at that yet. So let's say, let's make a local variable here called bid farewell. Okay. And then let's set that to point to a new proc object. And then we'll say proc.new, open up a curly brace here. And then what we're going to want to do is we're going to pass in a name, kind of how we did up here when we go to call this. Now the way we do that with a proc here is that we just define a block argument here. We'll just say name, and then we can say puts goodbye, oops, and then we'll interpolate name here, close off our string, add a closing curly brace here. We'll hit enter on this, and now we can say bid farewell dot call, and then we'll pass in my name again. We'll hit enter on that, and then we see that we get goodbye Colin. Now let's look at a key difference here between lambdas and procs. Okay, we're going to use these last two that we created here. So the greet person and bid farewell. We're going to use these two, as both of these take arguments. So here's one a big key difference here between procs and lambdas. Let's look at what happens if we say greet person dot call and we don't pass any arguments. So here we see that we get an error for an argument error. We gave it 0 arguments, but it was expecting 1. Okay. Now let's look at what happens when we say bid farewell dot call and we don't pass it any arguments. If we hit enter here, we see that we get no error, and it just prints out the string for us. And the block variable name in this case was nil, so it just doesn't put anything there. We just see our goodbye comma, and that's it. So that's a big key difference. So the next difference we're going to talk about is how the lambdas and procs handle the return keyword. So what we're going to do here is we're going to make 2 methods to illustrate this. So let's say def lambda return example, just like this. So let's start off just with a put statement. So we'll say puts inside method body, okay? And then let's create a lambda here. I'm just gonna say L equals, and we'll do a stabby lambda here. L equals, let's just say this is our return example. So we want to say return, let's just say return 5, okay? Now we want to make sure to call this lambda inside the method here. So we'll say L.call. And then now let's write a put statement and just saying after lambda call, okay? And then let's end this method. So that's our first one. Let's make the equivalent for a proc object now, and actually instead of writing that all out, I'm just going to recall this and make some changes here. So I'll say instead of after lambda call, I'm going to say proc call. I'm going to rename this to P. Same thing up here. We'll keep the same return here, but we're not going to use this stabby lambda syntax here. We'll use proc.new so that we can actually get the real difference. And then we'll rename this to proc return example, just like this. So let's double check ourselves. Def proc return example. Inside method body, that's fine to keep the same. P equals proc.new. We want to make sure to make a proc object and not a lambda object here. We still want to make sure to call it. And then we're going to try and print out after proc call at the end here. So what we're going to see happen here is that in the case of the lambda, we will see that all of this code within this method body is going to run. So even though we called return right here, normally inside a normal method body, if you just say the return word, let's say we have a method that's 5 lines long, right? If you have a return statement on line 3 that will execute, when you hit line 3 there, it's going to return out from the context of that method, meaning the lines 4 and 5 will not be run, okay? However, we're going to see some interesting behavior here. In the case of the lambda, it is only returning within the context of that lambda, and the rest of the methods, the rest of the lines of code here are going to run after we do this call right here. So we will see this put statement executed. However, in the case of the proc object, it behaves much like the method example I just spoke about. So when we hit this call right here and it runs this return 5, we're going to exit completely out of the context of the method itself. So we will not see this line run and print to the terminal here. So let's call these two methods. Let's do lambda return example. Okay, so we see printed to the screen, we see inside method body and after lambda call. Okay, so that means our code ran all the way through this whole method, right? So let's look at now calling proc return example. If we do that, we see that all we get is the inside method body line run, and the return value from that method has been 5, which is what we specified to return right here. Again, the reason we got nil though in this first case when we called our lambda return example is because nil is the return value from a put statement. So even though we see something printed out with puts, that is not the actual return value from puts. Nil is. So that's why we see the nil here, and then we see the 5 here because that was what we told this proc to return here. And when we called it, that ran, and we just printed out, or we just returned 5, printed out that first line, so we never hit this line of code here. All right, so I think that's where we're going to end our intro to loops and blocks video here for this section. In the next section, we're going to have our first look at writing our own classes. So I will see you over there.